how to differentiate inverse trigonometric functions. So if first of all you need to understand what is a inverse. For example, if you are given a function like y is equals to 3x minus 2, and it means by transposition, it means now x will be y plus 2 over 3. That is the inverse. So for trigonometric function, for example, y is equals to the sine of x. So if y is equals to the sine of x, then it means that x is the sine inverse of y. So if you get the sine inverse of y, you get x. Let's say you have y equals to sine 30 degrees. It means your y is a half. So and now our x is 30. So if we need x, then it means you have to find the sine inverse of a half. So you want to look at how do we differentiate this kind of functions. For example, I've said find dy dx. Find dy dx of y is equals to sine inverse of x. So you are saying that if y is equals to the sine inverse of x, so it means we can write it, so we can have now x is equals to sine y. It means x is equals to sine y. That's the same like here. Here we have x is equals to the sine inverse of y. So if you need y will be equals to sine of x. So the same here, if y is equals to sine inverse of x, so it means here your x is equals to sine y. Then at this point you can find dx dy. So from standard derivatives we know that if you differentiate sine you get cos. So you have cos y. So you are going to use trigonometric identity. We know that cos squared theta plus sine squared theta is equals to 1. So you can make cos squared theta the subject. So it will be, this one goes to the other side. It will be 1 minus sine squared theta is equals to cos squared theta. So if you want cos theta, this one is squared, so we get the square root on both sides, this side and this side. So cos theta will be the square root of 1 minus sine squared theta. So you can use this expression to substitute for cos y. So it means cos y is equals to the square root of 1 minus sine squared of y. So we have dx dy is equals to the square root of 1 minus the sine squared of y. So we want dy dx, and we have dx dy. So the inverse here shall have dy dx. Then the inverse on this side we have 1 over the square root of 1 minus the sine squared of y. So you have just get the reciprocal on both sides, so that we have dy dx, which we want. But we have sine squared of y, but we know what is our x. But x is equals to sine y. So we substitute. So your final answer will be dy dx will be equal to 1 over, now the square root of 1 minus sine squared y, but sine y is x, so sine squared will be x squared. Up to there, now you can follow this example and do the other derivatives of inverse trigonometric functions.